I'm Anil Kumar. In this video, we'll learn how to find distance from a point to a line in R2. The question here is, for each of the following, find the distance from the point Q minus 2 minus 3 to each line. So we have lines in different forms. The first one is the Cartesian equation, 4x minus 3y minus 12 equals to 0. Then we have x minus 1 over 2 equals to y minus 2, y plus 2 over 3, symmetric form. The vector form of the equation, r equals to 1 comma 2 plus s times 3 comma 2, where s belongs to real numbers. And then we have horizontal and vertical lines. X equals to 5 being the vertical line, y equals to minus 2 being the horizontal line. So the basic idea here is that in any coordinate plane in R2, if we have a line, let me sketch a line, for example, like this. In that case, the shortest distance is along the normal, right? So if this is the line, then the normal could be kind of like this. This is the normal to the line, right? If you want to find shortest distance from a point Q, let's say the point Q is somewhere here. In that case, the shortest distance is in the same direction as the normal. So that is the shortest distance which we want to find. Correct? To find the shortest distance, what you can do is take any point on the given line. Let us say we know this point Q, which in this case is minus 2, minus 3. We know this point Q. Just find any other point on the line. Then, if this is the angle theta, in that case, PQ projection on the normal is the shortest distance, right? So basically what you see here is that the projection of vector PQ on the normal N gives the shortest distance. Is that clear? Correct? So the two formulas which you could use are, in case you know the normal, like you have the scalar equation, then the shortest distance D could be written as the absolute value of AX0 plus BY0 plus C over square root of A square plus B square, right? The unit vector along the normal. If you don't know the normal, that is, if you are working with parametric, that is, or symmetric, or the vector equation, in that case, you could get the projection using the dot product, right? So if you do the dot product of PQ with normal, you get QM in this direction. Is that okay? And when you divide this by the magnitude of normal, you get the distance of the point from the line. So we're talking about line L, point Q, right? So I hope the concept is clear. So basically, we are going to use one of these formulas to calculate shortest distance, right? So you can pause the video, copy the question, try it out, and then look into my solutions. Now, once we have done shortest distance from a given point, I will slightly change the question as an exercise for you. We'll find the shortest distance from the origin, right? So we'll just change same points I've taken. That means 0, 0, right? And then we'll end up with a multiple choice question saying the distance from origin to this line is what? Now let us see how to solve the questions which we began with. So part A was to find distance from a point Q to the line 4x minus 3y minus 12 equals to 0. Now since we know that this is in Cartesian form, the shortest distance D can be written as a x0 plus b y0 plus c divided by square root of a square plus b square, correct? Since we are given the Cartesian form. And always the distance is positive, so we'll take absolute value, right? So in this particular case, x0, y0 is minus 2, minus 3. A, b and c are 4, minus 3 and minus 12. Substituting the values, we get 4 times minus 2, minus 3 times minus 3, minus 12 over square root of 4 square plus minus 3 square. Right? So that gives you, we can use the calculator. 4 times 2 is 8. Minus 3 becomes plus 9 minus 12 over 16 plus 9, 25. Square root is 5. Correct? So that becomes your answer. So you have 9 minus 8 minus 12, which is a negative number. So don't forget to write down the absolute value. You have to always take distance as positive, right? So I'll keep 11 as such, and divided by 5 will give us minus 2.2. So we get absolute value of minus 2.2, which is equals to 2.2 units, correct? So that is how you'll find the shortest distance. So I hope the steps are clear. Now let's do part B, where the equation is in symmetric form. So the point given to us, Q, is minus 2, minus 3. The equation is x minus 1 over 2 equals to y plus 2 over 3. So from this equation, you can find what direction vector is. Direction vector m is 2, 3, right? So if 2, 3 is a direction vector, then the normal will be 3 minus 2, correct? And any point, you know one point here at least. So let's call that point P as 1 minus 2. 1 minus 2. Is that clear? Right? So that becomes the point. Now, what we need to do here is, we need to find what PQ is. So PQ will be equal to 1 minus 2 minus 2 minus 3, right, which is 1 plus 2 as 3, and here we get minus 2 plus 3 as 1. So PQ is 3, 1. Normal is 3 minus 2. So we'll find the distance using dot product of PQ with the normal divided by magnitude of normal. Is that clear? So that gives you dot product of PQ 3, 1 with normal 3 minus 2 divided by square root of 3 square plus minus 2 square, correct? So that is 3 times 3 is 9, 1 times minus 2 is minus 2 over square root of 9 plus 4, which is 7 over square root of 30, correct? So don't forget to write absolute values, right? So that's kind of important. Always write the answer with positive value. So that is when the equation is given in symmetric form. Now let us see how to do with parametric form. Again, the steps are exactly same. So the point Q is minus 2, minus 3. Point P is 1, 2 in this case. Direction M is given to us as 3, 2. Now since direction M is 3, 2, the normal direction will be 2 minus 3. Correct? And distance, as you now know, is PQ dot normal over magnitude of normal, and always we are going to take positive values. Clear? So PQ could be written as 1 minus, so let me write down. So PQ, this direction, will be 1 minus minus 2, which is 3. So right, 2 minus minus 3 is 5. That is PQ, right? Dot n, which is 2 minus 3 over magnitude of n, which is 4 plus 9, right? So I'm doing some shortcuts. So I hope that is clear. We wrote PQ as, or you can say QP, it's one and the same thing, 1 minus minus 2, and then 2 minus minus 3, correct? Which was 1 plus 2 and 2 plus 3. That is how we got 3, 5, right? So I hope that is clear, correct? Anyway. And now we can write this as 3 times 2 is 6, 5 times minus 3 is minus 15, absolute value of this over square root of 13, correct? So we get, again, 6 take away from 15 will be, let's do it, 9, right? So we'll do 6 minus 15. It gives you a negative value. We have to make it positive, right? So we have negative 9 over square root 13, which is 9 over square root 13. Is that clear? Right? So let's take up the next question, which is, now in this particular case, we are working with horizontal and vertical lines. So that is simple. We need not even use any formulas. X equals to 5, as you know, is a vertical line, correct? So this is x equals to 5. We have the point at minus 2, minus 3. Let's say this is the point. So the distance is definitely that distance from the line, correct? So it is, since this point is minus 2, minus 3, which is minus 2 units here, and this is 5 units, you can see that the distance here is equal to 5 plus 2, 7, right? Now, in case of the second line, when we say y equals to minus 2, the line is kind of like this, y equals to minus 2. So the distance from this is the vertical distance. So difference in the y values, correct? So, I'm sorry, the point minus 2, minus 3 will not be there, but I'm sorry for this. Minus 2, minus 3 will be here, right? So that is minus 3, correct? So we have minus 2, minus 3. So in that case, the distance which is from the line is this distance, correct? So we have minus 2, minus 3, which gives you a distance of 1, right? So this is 1 unit. So here the distance is equal to 1. But the idea here is, I like you to use the formula and verify, correct? So in this particular case, we are talking about the point which is y equals to minus 2. You can take any point on this line, however. A good point to take is the y-intercept, which is, let's say, P, you will consider as 0, minus 2. And we know Q is minus 2, minus 3, correct? Now, PQ is equals to, we can say 2, 3, 2. And minus 2, minus 3 is 2, 1. PQ is 2, 1. Now, what is the direction? M, and what is the normal direction in this case? So when I say y equals to minus 2, you are actually moving in this direction. Is it okay? So the normal to this direction is that direction. This is normal to this direction. Correct? So when you say normal to this direction, then from this point, you don't move along the x, however, you move along y. Correct? So you could use 0, 1 as the normal. That becomes a unit vector also, correct? So if you do dot product, that is PQ dot n over magnitude of n, you should get the same result. So which is 2, 1 dot 0, 1 over square root of 0 plus 1, correct? So that gives you 2 times 0 as 0 plus 1 times 1 over 1, which is 1 unit. Do you see that? So likewise, you could also do for the vertical line, right? So in this case, you could use a point P, which is 5, 0. Q is given to us as -2, -3, and slope M for the line is, you could say, M is along the y-axis, so it is 0, 1, and N, the normal, is along the x-axis, correct? So that becomes normal to this line. So you could say 1, 0, right? We are not putting any negative for 0. It doesn't make any sense. You could use this formula and verify that the distance is indeed 7. Is that clear to you? However, straight answer as I have given is good enough. Okay, so now let's take up the other two questions. So now the question for you is, for each of the following, find distance from the origin to each line. So we have kept the same lines. The only thing is point Q has been changed to origin, correct? Now if that is the case, what are the answers for each? If you are given equation in the standard form, if you substitute 0, 0 here, you get -12. So the answer for the first one will be -12 divided by a square plus b square, which is 4 square plus 3 square. And so we get 12 over 5, correct? So that becomes the distance for the first equation when you're given in the normal form. Now let's look at the other equations. Now, the point Q is 0, 0. So that means the point P becomes the position vector. So remember, now P is position vector now. So when we want to use this formula, PQ dot N over magnitude of N, absolute value, then the point itself is the position vector. So what we can do here is, in this particular equation, let me write down what the position vector OP is, right? Or you can say QP, right? OP and QP is same because Q is the origin now, right? Dot N we need. So what is OP? So OP in this case will be 1 minus 2, correct? So that becomes OP. In the second equation, OP is 1, 2. In the third equation, the point OP is going to be 5, 0. And in the last case, it is going to be 0 minus 2. So you could make a column for OP. Is it okay? Now, normal. Normal for this equation, you know the direction is 2, 3. So the normal will be 3 minus 2. Just flip and interchange the sign. In this case, the normal will be 2 minus 3. In this case, the normal will be, so this is the vertical line, see. Well, this is a vertical line. So the normal is along the x, correct? So normal is along the x, which is 1, 0. And this is a horizontal line. Normal is along y, which is 0, 1. Is that okay? So that becomes the normal. And now you can do their dot products. So you can make the third column of distance, which is OP or QP dot N over magnitude of N, the normal, absolute value. So you can do the dot product between these two, which is 1 minus 2 dot 3 minus 2 over square root of 3 square plus minus 2 square, correct? So likewise, you can complete and find the other results, correct? So I hope this you could complete and do as a practice. So this is your practice test. Okay. Now let's take the last question here, which is a multiple choice question. Treat it as a test question for it. The distance from origin to the line 3x minus 4y minus 15 equals to 0 is what? 5 choices are given to you. Remember, the distance has to be positive, so absolute value of from origin we are saying. So that means this becomes 0 plus 0 and this minus 15, right? Divided by a square plus b square square root 3 square plus minus 4 square square root, which is 15 over 5, correct? Which is equals to 3. So it is option B. So I hope with that the concept of finding distance from a point to a line in R2 is absolutely clear. So we'll take up the next video, distance from a point to a line in R3, and then we'll discuss distances involved when we have lines and planes or two planes. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks and all the best.